So welcome back to my YouTube channel, Dr. Vipin's Biotech and Bioinformatics Classroom. So I've given you a basic discussion on awk till now with a simple file, which was basically the marks obtained by students in a classroom. And now we move on to a slightly more complex file, that is your Fastq format file, which is typically the file that you get from your next generation sequencers. So we'll look into how awk can be used to parse this file to pull out a specific sequence, to check whether a particular pattern is present in your sequence or not, to convert a file from Fastq format to fasta format, and so on and so forth. So here we are, and up till now we've done a simple file like the distribution of marks in students in a given class. And I'm sure from the previous lectures you remember that the line is captured into $0 variable. And then the line is separated into fields based on a separator that you can define. So in this case, we define our tab as a separator. So the line gets separated into 7 fields. And these separated fields are stored in the variables $1, $2, $3, $4 until $n, until as many fields that are there. NF is number of fields, NR is number of rows, and $NF is the last field in the row. And you can go back again to the previous lecture to check details for this. So let's now move on to a more complicated file and biologically more relevant file. This is a Fastq file or a sequence file coming from next generation sequencers. Right? So this is a standard format that is followed for DNA and RNA sequence data that is coming from second generation and third generation sequencers. So here, if you see, this is a typical Fastq file, and it is called a Fastq file because it also carries the quality scores for a given sequence within the file. If you look closely into the file, you'll see there is a pattern to the file. You have one sequence record represented by 4 lines, as is indicated in this white highlighted portion. And within these 4 lines, you have the first line, which starts with an @ sign, and then it has a unique identifier. This is the identifier line. Then the second line actually represents the sequence line or the nucleotide sequence obtained from the DNA fragment that you are reading. The third line in this case is only having a plus sign and nothing else. In some cases, it will also have the identifier again pasted here. The fourth line is an encrypted quality score line. These are ASCII characters, and they represent the quality of the base call in each of the nucleotides that is called on the second line. So if you see, there is a correspondence between the number of letters that you have in the sequence file and in the quality score file, right? So the length of the sequence is exactly the same as the number of characters represented in the quality score line. And these are encrypted scores coming from the Fred software and represented as ASCII characters. So this is typically what is a Fastq file. Now, before the advent of the next generation sequencers, the major sequence format in which the DNA or protein sequence was represented was what is known as the FASTA format or FASTA format. So the FASTA format is simple. The first line on top begins with the greater than sign. That is a major indication that the sequence is in FASTA format. And then it is followed by some definition of the sequence. It may contain a unique identifier, an accession number, also a brief description of what the sequence is. So this is your identifier line here, or the def line, begins with the greater than sign, followed by some description of the sequence. And then from the second line onwards, you have the sequence itself, right? And then, of course, you can see this is a multi-FASTA file because there are multiple sequences in FASTA format here. So let's now move to awk and see how you can parse a Fastq file and derive some information from it, and also convert a Fastq file to a FASTA format, right? And if you want to understand the next generation sequencing techniques in more details, you can refer to my talk again on my channel. This is entitled Next Generation Sequencing Techniques and Applications. This is a webinar that I'd given at Hindu College in 2020. Let's now move on to our terminal and start working with awk. So we are back to a Linux terminal, and let's now parse a Fastq file using awk. So I'll use the cat command to have a view of the file. So I say cat, and then I say sequence sequence.fastq, right? And you press enter, and this is a huge file. It has a large number of lines, so this will keep continuing to scroll for a very long time. So I'll just stop the scrolling by pressing Control-C, and then calculate the number of lines in this file first. Let me clear this out. So visibly, this is a huge file. So let's now first count the number of lines that are present in our file. So we can use both the Linux commands and awk to count the number of lines in your file. So first we do it via the Linux commands. So you say cat sequence sequence.fastq. That's the name of the file, and you pipe it with the word count command wc, and because you want to count the number of lines, you say -l, and you press enter. And so now if you see, this has 9,43,628 lines, right? So now you do the same thing with awk, and you remember that in awk, the row number is basically in the nr variable. So if you print the nr variable after the file has been read, then you'll be able to get the total number of rows in the file, right? So to ensure that the nr variable is printed after the file has been read, you start with end and then say print nr. So here you are, you say awk, and then you open your apostrophe, then you say end. And then once the file has been completed read line by line, you are printing the NR. So you say print and you say NR, right? So this is the action. Action has to be within the curly brackets, and then you close your apostrophe, give the file name. So this is sequence sequence dot fastq, and you press enter. So now let's say you want to calculate the total number of sequences in the file. And we already know that in Fastq format, one sequence data is represented by 4 lines. So if we divide our total number of lines by 4, we will be able to get how many sequences are there. So we say again awk, and then open the apostrophe, then we say end, and then we say print, and nr divided by 4, and we keep this, close the round bracket, close the curly bracket, close the apostrophe, and you mention the file name, and you press enter, and that should give you the total number of sequences that are there in your Fastq file. So here you are, this is 2,35,907, and this is exactly 1/4 of the total number of lines that are present. If you want to see that again, we can take you back to that command, right? So this is your total number of lines. And this is exact 1/4 of this number of lines here, right? So one good practice in programming is to work on a small sample data set. The advantage with using a smaller data file is that you can manually also calculate what is the expected result. So this will help you identify whether your program is giving you the correct output or not. And if your program is giving a correct output for a smaller sample set, it will work the same way for a larger sample set. So therefore, what we do is we create a small subset data from our larger data here. So let's say we want to take the first 20 lines or 5 set of sequences from the start of the file, right? So we say head, and then we define the number of lines we want. So we say -n 20. Why 20? Because we know that one sequence data set is represented by 4 lines, and 20 would include 5 sequence data sets, which will be manageable even manually. So therefore, we take 20 lines, and then we give the main file name, which is sequence sequence.fastq, and we write it into a new file by using the greater than sign and giving the file name seq.fastq, right? So let's have a look at a new file. So we can say more seq.fastq, right? So here is our file. You can see that there are 5 set of sequences. So let's now very quickly calculate the number of lines in this file. So you say again awk apostrophe end, and once the file has reached the end, you say print nr, right? And then you close your apostrophe, and now the sequence file name is sec.fastq, right? And you press enter. So this is 20 lines. You also know the number of sequences that are there. That will be nr by 4. So you can say nr divided by 4. That gives you the number of sequences that are present. So let's say now you want to see the file along with the row number. So you say awk, and then you open an apostrophe, you say print, and you say print nr, which is the row number, and then you give a separator, let's say /t, right? And then you give your $0, which is the carrying the line that is being read as of now, right? So then you close this, close the apostrophe, and again you say seq dot fastq, right? And you press enter. So here is what is your line now. So this is your line number 1, which is your identifier. Line number 2 is your sequence here. So if you look at what is the line numbers for the line that carries the sequence, this is 2, 6, 10, 14, and finally it is 18, right? So the point that we're making here is that every time you're looking at a row that carries the sequence, the row number can be divided by 4, and every time the remainder will be a 2. Likewise, every time you're looking at the row number that carries your identifier, for example, here, this is the 1. So 1 divided by 4, the remainder is 1. 5 divided by 4, the remainder is 1 again. Then 9 divided by 4, the remainder is 1 again. Then if you look at 13 divided by 4, the remainder is 1. And likewise, 17 divided by 4, 4 4 is 16, the remainder is 1. So the important point we're making from the nature of the file is that the line that carries the unique identifier, if the row number of that line is divided by 4, the remainder is 1. Likewise, the line that carries the sequence, if the row number of that line is divided by 4, the remainder is 2. So we'll use this to catch the row that carries the identifier line and also the row that carries the sequence line. So let's clear this out, CLEAR, and we press enter. Now let's say you want to print all lines that contain your sequence, right? So you know now that if you look at the row numbers of the lines that contain the sequence, the remainder is always a 2, right? And you will also remember that if you want to use your Linux terminal as a basic calculator, you can say BC, and this now transforms into a basic calculator. So the way you calculate the remainder for a given division is by saying x%y. So let's say you want to see what is the remainder of 2 divided by 4. So you say 2% 4, and you'll get a remainder of 2. Likewise, 6% 4, and you still get a remainder of 2. 10% 4, you get a remainder of 2. 14% 4, you get a remainder of 2. And if you remember again, these are all the lines that represent your sequence in your Fastq format. The second line, the 6th line, the 10th line, the 14th line, and the 18th line, right? So let's get back. You can come out of the calculator by pressing Q. No. So you can come out of the calculator by saying quit. Yeah. Right? So you come out of the calculator by saying quit. And now we go back to our file again. And we want to now print only the sequence and nothing else from the file. Right? Awk, open the apostrophe, and we say nr row number percent or should be equal to 2. So you're not assigning a value of 2. You're using double equal to, which means you're saying that the value on right-hand side should be the same as the value on the left-hand side. So the remainder of the division of the row number by 4 should be equivalent to 2 is what you're saying. And if this is true, then you're saying print $0. Right? So you're only printing the lines that contain your sequence and nothing else. And then, of course, you say seq.fastq, which is your file name, right? And then you press enter here. We forgot to put the apostrophe. So let me just Control-C here, and we put the apostrophe. So that is, the syntax has to be satisfied. So here you are, and you press enter. And here are your sequences alone, right? So you have only the sequences and nothing else. Let's say you also want to print the length of the sequence alongside the sequence. So you can, again, modify this command a bit. So we use the same command, print $0, and then you say /t as a separator, and then you say length, length $0, right? So this length command will calculate the number of characters that are present in the sequence. And you press enter again, and here you are. So the first sequence is 149 base, the second one is 161, and you can see visibly it is a little longer. This is 161 again, the third one. The fourth one is slightly still longer. This is 166 bases, and the fifth one is also 166 bases, right? So let's say you only want to print length of the sequences and nothing else. So you can go back to the previous command and you can delete the $0 and the /t here. So we can remove this. And now we are printing only the length of the sequence that is present in the particular sequences. And again, how do you match the line that has the sequence? That you're giving by giving this condition, nr%4 is equivalent to 2, which means that when the row number or nr is divided by 4, the remainder must be 2. So here you are, and you press enter, and you get your length of the sequences only, right? Now, let's say you want to convert the Fastq format to fasta format. So remember the fasta format and Fastq format, there is a bit of a difference. In the Fastq format, there are 4 lines. In the fasta format, there is only 1 definition line followed by the sequence itself. There is no quality score line in the fasta format. And in fasta format, the first line or the definition line must begin with the greater than sign. So this is the awk statement that will help you do this. Let me explain it to you how this works. So first we say awk, open the apostrophe. Then we are first looking for the line that carries our identifier. So we say nr%4, and the remainder must be equivalent to 1. If this is satisfied, then A is equated to $0. So in this case, the $0 is going to be your identifier line in case of our file here, right? Then we are also checking whether the row number divided by 4 gives you a remainder of 2. Remember, this is going to be your sequence line. And if this is true, then we say print. First, we print the greater than sign because that is the characteristic feature of the FASTA format. Then we print A, which is the identifier for the sequence. Then we give a /n, which is to say that this is the end of line character. So the sequence will now be printed at the next line after the identifier line or the def line, and then you print the sequence, which is in $0. Then you close your curly brackets and you close your apostrophe, and then of course you give your file name. So this is how the awk is going to work and convert a Fastq file to a fasta file, right? So what we're doing typically is we're catching 2 lines from the Fastq format, one the identifier line and second the sequence line, and then we convert it to a fasta or fasta format. We first print a greater than sign, then we print the identifier on that, the same line. Then we give an end of line character and then print the sequence from the next line onwards. And here is your FASTA sequence of the same Fastq file. So this is your identifier line here, and then the first sequence, the second identifier, its corresponding sequence. Let's say you want to catch sequences with a specific substring or a specific subsequence. And then if the subsequence is present or the pattern is present, then you want to print those lines in the FASTA format. So now you're giving multiple conditions. First, of course, if the remainder of the row number divided by 4 is equivalent to 1, then you know that this is your line that contains your identifier. So you're capturing the identifier. Then if your row number divided by 4, the remainder is 2, you know, there's a sequence. You're capturing the sequence here. But also you're matching that this sequence must have the expression GGACAG. If this is not matched, then you're not printing. So you're giving 3 conditions now. One is you're capturing the identifier by checking for the remainder of row number divided by 4 must be equivalent to 1. Then you're checking for the sequence line by checking whether nr%4 is double equal to 2. And then you're also checking for whether the pattern that you want is matched to your sequence here. So you say $0 is matching to, the tilde sign indicates match, is matching to GGACAG. So this is kept within 2 backslashes. There's a regular expression that I'm looking for. If this is met, then in that case, you print first a greater than sign, then the identifier, which you've already caught in a variable, then your new line character, and then finally the sequence. Then you close your curly brackets and also close your apostrophe. And then, of course, you give the sequence file name, that is sec.fastq. So let's press enter here and see whether this works out or not. So you are looking off the set of 5 sequences that you have. You're looking for only the sequences that have a matching pattern GGACAG. So you press enter here and you get 2 sequences where you have GGACAG present. GGACAG in the first sequence, and likewise you have another sequence here, GGACAG. So of a set of 5 sequences that you had, only 2 had this expression matching. Now let's also say you want to calculate the average length of sequences in your file. So let's say now you want to calculate the average length of reads in your file. So here is the awk code for calculating the average length of the reads in your file. So you say awk, you open your apostrophe, you say begin, and at the beginning, you basically initialize a counter known as sum to 0, right? This is where you're going to sum up all the lengths as you read your file line by line. We can identify the line that contains the sequence by the simple notation that when the row number is divided by 4, the remainder is 2. So whenever you get to a sequence line, you are basically incrementing your sum counter with the length of the line that carries the sequence. And you keep doing this until the end of the file. Once you reach the end, now you print the sum divided by the row numbers divided by 4, because as we've already seen, the number of sequences would be 1/4 of the total number of lines that are present in your file. So your row number divided by 4, close your bracket, close your apostrophe, and then of course you give your file name sec.fastq and you press enter. And here is your average length of sequences. Let's see what is the average length of sequence in the larger file. You say sequence sequence.fastq, right? And you press enter. And here you are. So on an average, the length is 150.16. This is how you can use awk to parse your Fastq format file. So we stop here, and of course, I have a lecture promised on sed. So we will talk about sed in the next lecture. And also, if I may request you, I want to expand quicker and faster. So if you could just share my channel in your friend circles on WhatsApp and on your social media, it will be very helpful. Thank you very much. Take care, and I see you again with a lecture on sed. Right? The third line may just have a plus sign as shown in this file here, or it may also contain the identifier along with the plus sign.